Okay, we're going to be looking at bearings and right angle triangles. Okay, so we've only got a couple of examples. So a ship leaves port, there's the port, on a bearing of north 730 east, so that's the bearing of the ship, for 6 kilometres. How far north or south is the ship from its starting point, and how far east or west? So you can see that we need to make a right angle triangle. Now the right angle triangle could come vertically down or could come across. It makes sense to go across so then that the angle is inside the triangle and then the right angle is up the top. Now just to make sure we don't get too cluttered, I'm going to draw the triangle again. Okay, so there's your 30 degrees, there's the 6 kilometres. Okay, so the first question is how far north or south? Well, the ship will be south. Okay, so the ship, how far will this, okay, there's the ship. So the ship will be north, so let's say that the first answer will involve that distance x, so the ship is north. And how far east or west? Well, we can call that, so there's my right angle, sorry. We can call that direction the easterly direction, and that will be the answer to that second question. Okay, so we're just going to use right angle trigonometry. So first thing you do is label the sides. So opposite the right angle is the hypotenuse. Opposite the angle is the opposite, and then the last side is the adjacent. Okay, so we're going to use, for x is adjacent and hypotenuse, so we're going to use cos. So cos 30 equals adjacent over hypotenuse. So x will equal 6 times cos 30. Let's just get my calculator out. And make sure your calculator is on degree mode. 6 times cos 30 equals, my calculator's in radian mode, I'm just going to stop for a sec. Okay, my calculator's in radian mode, so I've just changed it to degrees. So 5 point, it doesn't say any decimal places, yes it does, 1 decimal place, so 5.2, and the unit is kilometres, so that's the first answer. Second answer is the opposite, and hypotenuse, that's going to be sine, so sine 30 equals y over 6, so y equals 6 times sine 30 equals 3.0 kilometres. Okay, copy that and come across. Okay, so the next one, consider the points O, A, B, C, D, E. Now I've just copied this from a textbook. We may not use all the points in these questions. Okay, so we're going to find bearings of A from O. So we need to find, the first one is going to be what's that bearing, so that's the A question. That's that one there. D from O, okay. Do we have to give them, oh yeah, we have to give them as true bearings. So we're going to have to find that angle and then add 180 degrees. B from C, so what we're going to do is in these ones here where they change, we're going to set up another little compass here, and we're going to find that bearing there, B from C, and E from C, so we're going to have to find we're going to have to find that angle and then add 180 degrees. So we'll do it step at a time. Okay. So I'll draw it again. So there's O, there's A. So A is 2, and we're going to try to find that angle there. So it's going to be that distance there is 2 and that distance there is 2, so we're going to use a tan relationship. We don't know that number, so that's the hypotenuse. So we're going to say tan theta equals 2 over 2, which is 1. So theta equals tan minus 1, which is 45 degrees. So the first answer will be O45, true. Okay. Next one we're going to do is D from O. So there's O, D, 2. So the numbers that we'll use are going to be 3 and 2, and we're trying to find that angle there, and then we're going to add 180 degrees to get the true bearing. Okay, so we're going to have tan theta again equals opposite over adjacent, and we're going to go to 1 decimal place. Okay, so shift tan, so tan minus 1, 3 on 2. Equals, so that's 56.3, and so the bearing will be 180 degrees to get to that position plus it, so it's going to be 180 plus 56.3, which is 236.3 degrees. Okay, that's that one done. Okay, B from C, draw it again. Now this time C's in the middle, not O, and so yep, C's in the middle. So we're going up to B, so B's up here somewhere. We're going up that way. So we're going across 2. So we're going across 2, and we're going up 3, we're going up 4. Okay, and that's going to be the angle at the moment, and then what we'll do is we'll find out the missing angle after that. Alright, so I've gone across 2 and up 4, across 2 and up 4, so tan theta equals opposite over adjacent, which is 2, so theta equals tan minus 1, 2. Equals, so I got 63.4 degrees, but the angle is not in the right position, so the bearing will be that angle, so the true bearing will be 90 minus 63.4 minus 90 equals, so that's 26.6 degrees, and that's true bearing, so that's that angle there. Okay. Last one, running out of colours, E from C, so we're doing that one there. So from C, put C in the middle, okay, so C's in the middle, and then E's up here somewhere. We're not drawing to scale. Okay, so we're going across, and then up, so going across 2, across 4, so going across 4, and then we're going up 3, we're going up 4 as well, and that'll give us that angle there, and then the true bearing will be 270 degrees plus that answer. So tan theta equals 4 over 4 equals 1. Use your calculator, that gives us 45 degrees. I know my numbers for that one, and so the bearing will be 270 plus 45, which is 315 degrees. True. Okay, so that's some examples on how to use bearings with right angles. Okay, thanks, bye.